we're given a certain mass of rutile, titanium 4 oxide, and we're going to react it with carbon and chlorine. In order to calculate the mass of titanium 4 chloride that we can produce. Now, there's some more information that talks about the actual amount of titanium 4 chloride that's produced. And we're going to calculate the percent yield based on all that information. Here's a picture of yellow crystals of rutile on hematite. And rutile and ilmenite are two very important minerals that industry mines when it comes to the production of titanium. I've got a link at the end of this podcast to a video which describes the Kroll process, which is a very common industrial process for the production of titanium from titanium 4 chloride. It's very interesting. If you've got a few minutes, I urge you to watch it. Back to our calculation. Let's see, what are we given? All right, we're given this mass of titanium 4 oxide. Well, remember, balanced chemical equation doesn't tell you mass relationships directly, it tells you mole relationships. And when you do a stoichiometry calculation, you have to put things in moles. So we need the moles of titanium 4 oxide. Ignore the 2 in front of the substance in the balanced chemical equation. That comes in later. It could be a 5, 10, or 15 in front of there. It doesn't matter. It doesn't affect the molar mass of TiO2. We want to calculate the mass of titanium 4 chloride that we can produce. It says theoretically be produced. That just means do the stoichiometry calculation. So we need the molar mass of titanium 4 chloride. And the same thing, ignore the coefficient in front of the TiCl4. That comes in later. We're also told the mass of titanium 4 chloride that's actually produced. And it says, what's the percent yield? That's the second part to this problem. We can't do that part until we do the first part. So let's ignore everything about the mass of titanium 4 chloride that's actually produced. Let's throw that away for right now. So right now, it's a stoichiometry problem. So you focus on the roadmap for that. We've got the mass of one of the substances. So we'll start with that. And first thing, you need to use the molar mass after this. It's because the balanced chemical equation gives you the mole relationships. So we're going to multiply or divide by the molar mass. Divide. Make the units work. Okay, so right now we have moles of TiO2. Well, that's not what we want when we're done. That's what we have right now. So now, this is where the coefficients come in. Divide by the coefficient for the TiO2. That means 2 moles of it. And then what is the calculation request? Well, we're working towards TiCl4. So we put that in the numerator. That's the only place the coefficients go, right there. Now at this point we have moles of TiCl4, but we do want mass, we want grams. So now we have to use the molar mass. Do we multiply or divide by the molar mass? Yeah, multiply. Make the units work. In fact, let's do our unit check all the way through. Okay, the problem says we want grams of TiCl4. Those are the units we have left over. 3 significant figures because of the 9.70. As far as a conceptual check, it's hard to do. We're ignoring 2 of the reactants because those are in excess, carbon and chlorine. We're ignoring 2 of the products, carbon dioxide and carbon monoxide, because we're ignoring it. So if you're going to check this and you have time, the best way to do is to go in reverse. Start with the mass of TiCl4 and then go backwards and calculate the mass of TiO2 that you need. Okay, so that's the theoretical yield right there. That's the stoichiometry calculation. The second part of the problem says, hey, this is what's actually produced. What's the percent yield? So remember the formula for that. It's actual yield divided by theoretical yield times 100, and that gives you percent. So we're told the actual yield goes in the numerator. And what do we divide by? What's the theoretical yield? That's what we just calculated previously. Now, common sense check. Less than or equal to 100. If it's more than 100, then there's a mistake somewhere. You have to go back and find what's going on. 3 significant figures because both the numerator and denominator have 3 significant figures. As far as the 94.3, well, it's less than or equal to 100. Other than that, you don't really have a conceptual check for that. If it's an industrial process, they like their percent yields to be pumped up really, really high because the farther away they are from 100%, the more it costs for them to make their product, and those costs get passed on to us as consumers.